In this video, I'll derive the equation for the capital efficiency of Uniswap V3. If we were to add the same amount of tokens to Uniswap V2 and Uniswap V3, then how much more can we increase the liquidity in Uniswap V3 if we were to narrow the price range? We'll say that delta L3 is the liquidity delta in Uniswap V3. When we add tokens to Uniswap V3, this will increase the liquidity. Here we're labeling it as delta L3. The liquidity delta in Uniswap V3 can be written as the amount of tokens that go in and the price ranges. How I derive these equations are discussed in another video, which I'll put in the descriptions below. We'll also say that delta L2 is the liquidity delta in Uniswap V2. If we were to add some tokens to Uniswap V2, then the liquidity will change and we'll label this as delta L2. In Uniswap V2, the liquidity delta can be expressed as the amount of tokens that go in and the current price. Again, this is discussed in another video, which I'll put in the descriptions below. The main goal of this video is to derive the equation that the capital efficiency of Uniswap V3 is expressed in this equation. 1 over 1 minus the price ranges P of A over P of B raised to the power of 1/4. As a quick example, let's calculate the capital efficiency if we were to provide liquidity plus minus 2% of the current price P. Plugging numbers into this equation, we get that capital efficiency of Uniswap V3 within the price range plus minus 2% of the current price will be 1 over 1 minus 0.98 divided by 1.02 raised to the power of 0.25. This is approximately equal to 100.487. In other words, if we were to provide the same amount of tokens to Uniswap V2 and Uniswap V3, the amount of tokens are delta X and delta Y. However, in Uniswap V3, let's say that we provide the liquidity for the price range plus minus 2% of the current price, then the liquidity in Uniswap V3 is about 100 times greater than in Uniswap V2. Okay, so let's now derive this equation. The big idea to derive the equation for the capital efficiency of Uniswap V3 is that we're going to compare the change in liquidity between V2 and V3 for the same amount of tokens delta X and delta Y. In other words, we're going to calculate the ratio of liquidity delta for Uniswap V2 and for Uniswap V3. Delta L3 over delta L2. This is equal to, the top part, delta L3 is equal to delta X over 1 over the square root of P minus 1 over the square root of P of B. How about the bottom? The bottom is equal to delta X times the square root of current price P. We can cancel out the two delta X's, the one on top and the one on bottom. Simplify the equation, and then what is this equal to? Well, this is equal to, the top will remain the same, and then we'll need to divide by the square root of P. Divide this top part, which I brought it over here, divide this by the square root of P that you see over here. Okay, let's simplify this equation further. I'll bring the square root of P to the bottom of this equation. So replace the ones with a square root of P. And since we brought this inside to here, we'll just remove this. Okay, I see a square root of P over here and another one over here. So this simplifies to 1. And we get that this part will be simply equal to 1. I'll come back to this equation later, but for now, I'll just highlight this intermediate result. What we're going to do next is replace this current price P with another number. We're going to say that the current price P is the average of P of A and P of B, the geometric mean of P of A and P of B. Since this will be the average, P will be between P of A and P of B. The geometric mean of P of A and P of B is equal to the square root of P of A times P of B. We take this equation that I've highlighted in green, and then we replace this square root of P with the geometric mean of P of A and P of B, the square root of P of A times P of B. So let's simplify this equation. Replace the square root of P with the geometric mean. So this will be equal to, replace the current price P with the geometric mean, and we get this equation. Okay, let's simplify this part of the equation that I've highlighted in an orange box. So this part of the equation, the top part is the same. The bottom part, we rewrite it as the square root of P of B times square root of P of B. We have two square root of P of B's inside another square root. So when we simplify this, this will be simply be equal to the square root of P of B. This and this are the same. But now we have a square root of P of B up on top and another square root of P of B on the bottom. which we can cancel out. And what we're left with on the top is the square root of P of A, or simply P of A raised to the power of 1/4. On the bottom, again, we have a square root of P of B. This is simply equal to P of B raised to the 1/4. We have a P of A raised to the 1/4 on top and P of B raised to the power of 1/4 on the bottom. So we can simplify this equation to be P of A over P of B raised to the power of 1/4. Using this simplification, let's rewrite this equation. I'll copy the equation from the top, and we're going to replace this part of the equation with this P of A over P of B raised to the power of 1/4. Remove this, copy this equation, and then paste it here. We use this equation and then replace this part of the equation with this other form. This is the final equation for the capital efficiency of Uniswap V3. Now to get to this equation, we use delta x, but however we can get the same result if we were to use the equation for liquidity delta for delta y. In other words, we got this equation using this part of the equation and this part of the equation. However, you can get the same equation, the same result by using this part of the equation, equations involving delta y.